Hello students, today I am going to start this video on a new unit, Unit 4. The first topic of this unit is Pharmacology of Drugs Acting Central Nervous System. From the earlier unit, Unit 3, we have learned about a little bit on the topic nervous system as well as pharmacology of drugs acting peripheral nervous system. Okay. From the beginning, we have to learn about what is neurohumoral transmission. So, neurohumoral transmission is referred to the transmission of impulse through synapse and neuroeffector junction by the release of humoral, which means chemical substances. There are some basic steps in neurohumoral transmission, which is involve impulse conduction from the central nervous system to autonomic ganglia. Next, transmitter release from this autonomic ganglia and transmitter action on post-junctional membrane occurs. In this case, the post-junctional activity will also start and thereafter the termination of transmitter action will occur. There are some basic process of synaptic transmission in the CNS. Also there are some 4 fundamental process which are neurotransmitters. These neurotransmitters are synthesized in presynaptic neurons and released into synaptic cleft to rapidly stimulate or inhibit postsynaptic neurons. Example, acetylcholine, dopamine, norepinephrine or epinephrine. There are so many neurotransmitters are there which are divided in furtherly into 2 classes. Some of them are inhibitory and some of them are excitatory. Okay, next is neuromodulator. These neuromodulators are released by neurons and astrocytes to produce slower pre or post-synaptic responses. Example, carbon dioxide, locally released adenosine, some purines, peptides, prostaglandin, or so many are also there. Next is neuromediator. These neuromediators are second messengers that play a crucial role in elicitation of postsynaptic responses produced by neurotransmitter. They are cyclic AMP, cyclic GMP, and inositol phosphate. After that, a main or a fundamental process are neurotropic factors, which are mainly released by CNS neurons, astrocytes, and microglial and act longer than neuromodulator to regulate the growth and morphology of neurons and control long-term change in brain like synaptic plasticity and several changes are also there, mainly by affecting gene transcription by acting through tyrosine kinase linked receptors. Examples are cytokines, chemokines, growth factors. There are 7 processes in neurotransmitter actions. Firstly, neurotransmitters are synthesized from precursor under influences of enzymes. Here synthesized through precursor enzymes. This blue dotted or blue diamond shaped product are neurotransmitter precursors. Secondly, these synthesized neurotransmitters are stored in vesicles. These round shaped balls, which consist furtherly three balls, are called vesicles. Next step is neurotransmitter molecules that leak from their vesicles are destroyed by enzyme. Here, here, which are the leaked vesicles and destroying neurotransmitters by enzymes. Next, action potential cause vesicles to fuse with synapse and release neurotransmitter. Next, action potentials are helps the vesicles to fuse with synapse and release neurotransmitter. And this is the proper way to release the neurotransmitter, not like this destroying by enzyme. Okay, now the next procedure is some of it neurotransmitters bind with autoreceptors and inhibit subsequent neurotransmitter release, and rest of it bind to postsynaptic receptor. Here we can see this is the postsynaptic receptors are there. Some of them bind to autoreceptors to inhibit the release of neurotransmitter, and some of them going to the postsynaptic receptor to forward the function. After that, released neurotransmitter are deactivated either by reuptake or enzyme degradation.